Hi, welcome to this episode of ADF Insider. My name is Frederic Desbiens. I'm part of the ADF product management team. Today, we'll have a look at the new features for Maven integration in JDeveloper 12c. If you don't know what Apache Maven is, please stay tuned. In a few minutes, I will explain you what Maven is and what it can do for you. After that, there will be two extended demos. The first one will be about how to create a new Maven-enabled ADF application in JDeveloper 12c, and the other one will show you how to add Maven support to an existing application. Simply told, Maven is a build automation tool. It's got two defining characteristics. The first one is that everything in Maven that you need to configure is specified through a project object model file or POM file. A POM is an XML file that defines several things about a specific project. In Maven, a project is a software component. It could be a jar file, it could be a WAR file for a web application. The project, in the POM, you define for it its dependencies, and the dependencies can be on other projects. For example, my web application uses a jar file of reusable code that I have defined elsewhere, so I specify the dependency, the POM file. On the other hand, dependencies can be also third-party jar files, for example, that you will use from the public internet or from third-party providers. Okay, the POM file also defines the build order for a specific project, as well as the plugins that I will put to work, because everything in Maven, or nearly everything, is based on plugins, so you need to tell Maven which plugins will be used for your project. Another interesting thing about Maven is that it is based on the principle of convention over configuration. So we've got POM files to define the projects and the dependencies, build orders, etc. But normally if you do things the Maven way, you won't have to configure anything. So configuration, explicit configuration in a POM file is the exception and not the rule. The plugins in Maven, they really play a central role, because as I said before, most features in Maven are implemented through plugins. And the base plugins shipping with Maven do lots of things. They will take care of the build process. They will enable you to run unit tests. They will enable you to establish a link between the build process and the source control management system that you've got. For example, your Maven POM file can help Maven retrieve the code for your application from your SVN or Git repository. And also it's possible with Maven to build a full website of documentation for your project. And this will be done by generating the Java doc for the code, but also you've got the possibility to create web pages dynamically that you will be able then to deploy on any web server. The way the Maven support was added to JDeveloper 12c was through plugins. So already in the 11G version of JDeveloper, we were offering the OJMake and OJDeploy tools. Those tools, you invoked them from the command line, and they enabled you to compile from the command line exactly like you were in JDeveloper, and to deploy them after that to WebLogic server. So those tools still exist, but now what we do in JDeveloper 12c is that we offer Maven plugins for those utilities. So Maven can do everything that you were able to do with Ant before. The way plugins are working internally in Maven is very simple. Basically, each plugin exposes at least one goal. A goal is simply a task that the plugin will be able to accomplish. So if I'm using the command line and I want, for example, to use the compiler plugin in order to compile the code using the Javac compiler, then I will issue the command mvn, and then I will specify the plugin name, column, and the goal name. So in this case, it will be mvn space compiler column compile. And if I issue that command, it will simply compile the Java code for my project and all its sub-projects, depending where exactly I am in the hierarchy of folders. Now, those goals, they don't exist in a vacuum, and they exist in fact inside the lifecycle. So every goal in a plugin is linked to one or several lifecycle phases inside the Maven lifecycle. So what's the Maven lifecycle? Basically, it's just a list of named phases. And this defines the order for goal execution, because each goal, as I said, is associated to a phase. So on the right of the slide, I've got the names for the phases of the standard lifecycle in Maven. And as you can see, it's straightforward. First you process resources, then you compile, and then you take care of the unit tests. So you get resources for the test, you compile the code for the test, and you run them. After that, you've got the package step, which will create the jar or war or ER file, depending what exactly you're trying to do. And the install phase will put jar files or WAR files at a specific place on the file system. If it's a jar, it will be deployed to the local repository, the local Maven repository. We'll talk about repositories a bit later. And finally, we've got the deploy phase, where obviously we push the application's code to a specific application server somewhere. Okay, so this is the standard or default lifecycle. You can define your own life cycles, and there are alternate life cycles you could use. But whatever you do, each and every plugin is linked to at least one phase, and thus will execute at that specific phase in the life cycle. Another very important thing in Maven is dependency management, and in fact it's one of the strengths of the tool. So we already know that POM files define the dependencies. Those dependencies, when you compile, whatever you're doing about a specific project, when you execute Maven, when you execute a Maven goal, what will happen is that the dependencies will be retrieved from our repository. So this repository can be local, and then if we are talking about the developer workstation, the repository will simply be some folder somewhere, but the repository can also be remote, and then you have several public repositories on the internet from which the dependencies can be fetched, or you can define your own private remote repository. There are tools for that. One of the most widespread is Apache Archiva. So with Archiva, what you do is you simply host your own repository inside your network, and that way the requests for dependencies won't go outside your network if you don't trust random jar files coming outside your organization. But whatever you do, dependencies are always defined the same way in the POM file. And I've got an example of such a dependency reproduced from a POM file on the slide. So here the dependency is on the JSP runtime inside ADF. And this runtime is, it comes with JDeveloper, it comes with ADF. So typically when you are simply using JDeveloper 12c on your machine, JDeveloper will populate your local repository with those jar files. But we also offer utilities that will enable you to populate your private remote repository inside your organization. So you've got command line tools in order to populate the remote repository, or if you are simply using JDev, then JDev will populate your local repository for you, will manage it for you. And this I show it in the demo section of this Insider. Today's demonstration will be made on the Windows operating system. So the first step is to ensure that the Java Home environment variable has been set.
to check this, I use the echo command. I forgot the percentage sign here. So if it returns that, it means it hasn't been set. So I will access the variables and I will create in system variables a new one for Java Home. The value for the variable must be the root folder for a JDK somewhere on the system, and I recommend to use the same you are using in order to run JDeveloper 12c. So on my machine, as you can see, the path to this folder does not contain spaces. This is a best practice, and you don't have bin or any subfolder after that. So it's really the root folder for the JDK. So now if I go back to my command line, I see that, okay, the value hasn't taken effect, so I must open a new command prompt in order to get the new value. So let's check now. Yes, we're good. So with that done, we'll be able to run the Maven scripts on the command line as well as inside JDeveloper itself. Another thing we need to do before actually using Maven is to have a look at the Maven preferences inside JDev. So there are several entries in the category, but I must first load the extension. So 12c, like 11gr2, is built on an OSGI component architecture, and that means that not everything is loaded when JDeveloper starts. So this is why I had to press this button. And now, in the top level category, I can elect to use the Maven version bundled with JDeveloper itself, or to use an external binary, maybe a more recent one that I will have downloaded from the Apache website. So in this case, 304 is fairly recent. I can use that. So the various subcategories are very, very simple to understand. So in this first one, logging errors, I can modify the colors used inside the JDeveloper log for errors and warnings that are coming out Maven executions. In phases goals, I can define what goals and lifecycle phases will be available in the Maven context menu inside JDev. Repositories is probably the most important one. So here I can really specify the path to my local repository. So currently I don't have one set because I didn't use Maven before on that specific machine. So I will leave it blank because when I will create my first project, it will propose to me to create it. And we have entries for remote repositories as well. One interesting thing is that you can select to download and unpack the indexes for those Maven repositories on your own machine, and this speeds up the process considerably. So I will start the downloading and unpacking of the index on my workstation. So this is a background thread, so you see the progress at the bottom of the screen. I can do other things in JDev while it is downloading and unpacking. The fourth category in the Maven preferences is the settings window, and here you can activate a whole slew of predefined settings that you could have passed on the command line as well. And in this window, you can, type your own settings if you'd like. So it is really, really flexible in the way you can use it. Okay, but now we're done with the settings. We are downloading and unpacking some index data. And while it's doing that, I will create a brand new ADF web application that I will configure to use Maven as its build system. So I will select ADF Fusion Web Application and give it a meaningful name. So right? So for the two projects, the model and view controller ones, we accept the default values. And at the last step of the wizard, we can now select the build tool. So we can configure the project, or in fact the whole application, to use either Ant or Maven. And this is a new step in the wizard. It wasn't there in the 11G versions. So you can specify your own group ID, artifact ID, and version string. In this case, the default values suit me fine. And as you see, now since I don't have a local repository, it proposes to create it. So this is a Maven convention that by default, the repository will be located in the user folder under the .m2 subfolder. So at .m2 repository in this case. So I accept this because otherwise I would have to do additional configuration if I wanted to execute Maven scripts on the command line. One interesting thing is that, as you can see, we already see the POM file under the model project that JDev created for me. What is not visible, because there's a POM file for the view controller project as well, but what's not visible at this point is that the model and view controller projects are linked together by a top-level POM file. And this POM file it's not visible by default in JDev, but it's very, very easy to get to it. So what I need to do is to simply will close the project overview. You see the two POM files for the two projects. And now I go in the File menu, select the Open command. I will see straight away the POM file because this is the root for my application. And this root contains the top-level POM file for it. So I open this file. And by default, I will get a nice visual editor, exactly like you will do with ADF business components, view objects, or entity objects, for example. So this one is very, very simple. So we see the group ID, artifact ID, version string that we specified in the wizard, and we see the two child modules, so the model and view controller projects. We also see that there are no remote repositories referenced because we are simply using the Maven central one. There is no central repository for the JDev and ADF artifacts. What we do is that JDev will populate your Maven local repository with the appropriate jar files, and that's it. And we can see that in the Maven deploy logs here. So this one is empty, but this other one, we see that it deployed a whole slew of jar files. So here is, for example, ADF DVT faces runtime, and it goes for a long time because we are actually creating the first Maven project on that machine. All those dependencies that you can have configured using Maven are reflected in the editor. So we see the dependencies on the two projects, and we see also some plugins have been defined. So here I will just maximize the window. Okay, I've got a plugin with artifact ID OJMake and another one OJDeploy. So we are compatible in JDeveloper 12c with most public Maven plugins, but to compile and deploy, we rely on our own technology in order to ensure that everything you can do inside JDeveloper, you can do it using the command line under Maven as well. So now I will close this top-level POM file. Let's have a look at the POM file for the model project. So if I have a look, in the dependencies here, I see that there are no dependencies. Now let's initialize this project for ADF BC. So I check that box exactly like 11g for online database, and I create a new database connection on the trusty HR schema that ships with every edition of the database. So this is the XT running on my machine. And now when I do that, okay, there are lots of new technologies that are added to my project when I click on the OK button. Those technologies are added, and this modifies my POM file. So I see now a whole set of things that happened in my Maven deployment log. And if I open the POM file here, well, it's been modified, so I will save it first. If I open it, I can see now that I've got several dependencies. And those dependencies are exactly what I need in order to run ADF-BC. So I see the base-C4G runtime, MDS runtime, base-C4G security, Oracle domains. And the thing is, okay, we've got a visual editor, but everything, as always, can be looked at in XML format. So typically, Maven experts prefer to edit the XML file directly. You can do that without any problems. And we see here, for example, the configuration for the OJMake plugin that we'll use to compile, and there's one for OJ deploy a bit down the road as well. Okay, so now I've got I initialized the ADF-BC for this project, so let's create a few business components from tables. Now let's go to the view controller and create a JSF page. We're done. So now we've got a full web application ready to deploy. So in this case, I won't actually deploy using JDev or Maven. What I will do is to create an EAR file with the WAR file for view controller inside. So in order to do that, I won't use JDev. I will go straight to Maven on the command line. So the first thing I must do is to go to the folder where the code is. So on this machine, I'm using the My Work folder in order to host my projects. And now I see the top folder for my test application. The next step, I must invoke the Maven executable. And in order to do that, I must locate it. So typically, on this machine, the middleware home is Oracle middleware 12c. And after that, we go to Oracle Common, Modules, Org, Apache, Maven, in this case _304. In the bin subfolder, we've got the mvn command. And now I will simply select the package goal, which will create the EAR file I need for deployment. So this is a fairly long process because now I need to set up lots of things in my local repository, and at the same time I need to compile the code, package everything. So the first running is always longer. Typically, such manual invocations of Maven on the command line won't be part of your daily routine. You will do that when you need to test your POM files to ensure they will work in another context. Typically, that will be continuous integration. So the Hudson continuous integration server, for example, can use Maven POM files in order to control the build process. So it can be very, very useful to test your scripts before deploying to Hudson. Now, one thing really important is, since the Maven support in JDev 12c relies on OJMake and OJDeploy, you will need to install JDeveloper on the Hudson server as well. And that way everything will work properly. Otherwise, you won't have the executables for OJMake and OJDeploy. All right, what I will show now is how to add Maven support to an existing ADF 12c application. So as you can see right now, if I open any of the two projects I've got in this application, you can see that I don't have any POM files. So JDev 12c makes it very, very easy to add Maven support in that context. So the only thing I have to do is to open the new context menu, and then in the From gallery, I ensure to select the Maven option. And the first option I get is application POM. So this is the top level POM file for the whole application. So the name, the default name, we should keep it. Group ID, artifact ID, version, exactly as in the wizard when I was creating a new application. And I can add a description as well. So there is an interesting option here to generate POMs for project in this application, and you should typically you will choose it because you won't have any POMs for any of the projects, and then you check the checkboxes to add OJDeploy and OJMake support to the top level POM, and that way everything will work exactly as if you had created the application with Maven support out of the box. So now you see that I'm getting the top level POM file, and if I go in the application navigator, I can see that both the model and view controller projects have got POM files as well. Now at this point I could open a command line and package the application exactly like I did for the brand new one, and it will work.
After those demos, I hope you are as excited as I about the Maven support in JDeveloper 12c. It's really a huge improvement over the 11G series. And not only that, but we give you all the tools you need in order to populate your own private remote repository, which will probably facilitate the whole lifecycle management process inside your organization. Also, Maven support can be added to existing applications, and it's a huge deal. If you are migrating from 11G Release 1 or Release 2 to 12c, then you can add Maven support or use Maven as the build tool for those existing applications. It's very straightforward. And finally, don't forget that Maven is just a part of the puzzle. In order to get the full picture, you also need a continuous integration server, because Maven defines the build process, but you need some kind of process in order to execute the build process. And here, a continuous integration server like Hudson is really a powerful ally. That's it for today's Insider. I hope you liked it. At this point, I invite you to visit the JDeveloper website at oracle.com/technology/jdev. There, you will find downloads, tutorials, discussion forums, samples, the ADF Developer Guide, and much, much more. I'm Frederic Desbiens. Thank you for watching this episode of ADF Insider.